our project here, the Alaskan Layered Pollution and Chemical Analysis, with the acronym ALPACA, of course. This is a project that's been, we've been building up for the last couple of years. So with some support from a number of agencies, we were able to have a workshop in Fairbanks to start the process of designing a study that is meant to understand how air pollution behaves under cold and dark conditions, the type of conditions that you get during Arctic wintertime. So that's really the focus of our study, is to understand Arctic wintertime air pollution. And ALPACA began as an international effort, and it's kind of an umbrella effort. So there are many folks involved with it. We have a steering committee of 6 members, and it's international, and it doesn't really fund any research, but coordinates all the research. From the writing of the white paper, we came together to find important open questions about chemistry in cold and dark places, and that led to the writing of a white paper. Following that white paper, we put together a grant to NSF under the Navigating the New Arctic, NNA program, and we're very, very happy to be funded on that. That project is called Sustainably Navigating Arctic Pollution Through Engaging Communities, or SNAPTech. And so some of what I'm going to tell you about today are some of the SNAPTech efforts, in addition to the broader umbrella of the ALPACA project. Our goals in ALPACA were very broad and Arctic wide, while SNAPTech is a bit more narrow, as I'll describe. But I mention that because we really want to build out the core that we've gotten funded through SNAPTech to build a bigger project that will really get to the broader goals of understanding Arctic pollution and chemical behavior of that pollution. So for SNAPTech, our kind of goal is to understand the unique conditions of Fairbanks and North Pole winter air pollution, and both from a chemistry, natural science side, and additionally from a social perspective. So I'll tell you about some of that as we go through the presentation here. So to start off, I just wanted to show you a picture of Fairbanks in the winter. This is from the roof of a building downtown in Fairbanks, and you see 2 of the real things that contribute to pollution in Fairbanks in this slide here. First off, one of the things you can see, if you can see my mouse, is a pollution plume, you know, a combustion, some sort of stack emissions here. It's cold, and there's a lot of emissions into this airshed. There's some cars driving around and things like that. So there's a lot of combustion sources that are putting out pollution at ground level, largely related to the very cold conditions that we get during the winter time. And that's part of our problem. Part of our problem is also chemistry. So those pollutants are emitted and then they react and can lead to secondary pollution. We don't understand that very well under cold and dark conditions, so we want to study that. Another thing you can see is that when it gets cold in Fairbanks, you get inversions, temperature inversions, and these temperature inversions trap cold air down near the ground. And that cold, dense air sticks near the ground, and if you put pollution into it, it just stays there, it stagnates, and then there's warmer air aloft. Well, when you get this density gradient of dense cold air near the ground, you also get miraging, and in fact, you can see it in the picture. So if you look at these wave-like crests on these hills, those are actually miraged by bending of light by the density gradient of this temperature inversion. So this picture shows us really why Fairbanks has a wintertime problem. Strong inversions trapping pollution that's emitted, and a lot of pollution coming into the airshed from combustion sources, and then chemistry. So we've been working on this for a number of years, and during this last winter, we've been working with a number of groups to do some pre-campaign studies. I won't go through, you can read some of the studies there that have been going on, but we've been pretty active this winter, both myself and Jinshu Mao, who Barry Leffer mentioned. You can actually see Jinchu here, the French team, which was here in the winter, the November, December timescale, and then me. And then there's towers. So we're trying to understand the vertical nature of this pollution. And that was one of our goals for this winter, is to try and figure out the vertical nature a good bit so we could get ready for future field studies. Okay, so I want to show you a couple of science results. I'm a natural scientist who wants to understand this, an atmospheric chemist. So I couldn't help but show you a few slides on the recent results we've been getting. And this is just a really simple study we did to try and understand the vertical nature of the pollution and how shallow that inversion trapping is. So working with the CTC, Community and Technical College here at UAF, they have this building downtown, which is about 20 meters tall, something like 70 feet tall. And we just sampled PM 2.5, small particulate pollution, on the roof of this building and compared it to measurements at ground level. So the building is right here at where this green dot in the center is, and then we're going to compare to PM measurements, particle pollution measurements at 3 sites around that. So it's a simple idea to try and see how much pollution is trapped near the ground. Here are the results shown as diurnal cycles. So we see PM 2.5 in micrograms per cubic meter on the vertical axis here versus the hour. We actually use UTC as the coordinate, which is kind of useful because the day afternoon, the warmest part of the day, is here on the left-hand side. And then we go into the night where we have most of our pollution. And then you have the next morning on the right-hand side here. So what you see is during the day, the pollution levels in springtime, we call it springtime in January, February, March time scale here. When the sun comes back, we call it spring. The pollution levels get low. And then as the temperature starts to drop and the inversion sets in, what you see is pollution levels come up. At the roof of this building, the black line, we see there's less pollution than at ground level, something like a factor of 2 to even a factor of 4 less pollution just 20 meters above the ground level. So pretty amazing trapping of pollution. This is a period with very strong inversions. So this isn't what you see when there's cloud cover or something like that, where there's less inversion. So you see this strong trapping of the pollution. And then the neat thing you see is that in the morning, when the pollution comes down at ground level because of vertical mixing, the pollution actually comes up at the elevated level because you're mixing the clean air aloft with dirtier air at the ground. And the highest pollution at the roof of this building actually occurs in the morning, and then they all come together for the day. So this is telling us the vertical scale of the pollution is very shallow, tens of meters during the extremely polluted times. And that's something we didn't know before and something that's going to help us with the future studies we're doing here. Another thing that's a part of this is the emissions into this airshed. And a way you can look at the emissions is by looking at carbon dioxide, because essentially any fuel that we're burning here in Fairbanks, wood, oil, natural gas, all contain carbon and thus lead to carbon dioxide. So carbon dioxide is kind of a nice tracer of the amount of heat that's going into the airshed. And in collaboration with Charda, one of the Charda Roberts from Orleans in France, who came in the wintertime, we put in a CO2 sensor and are comparing here CO2 on the bottom to PM on the top right here. And what you can see is that the CO2, which is normally a background around here of about 420 parts per million, it's actually kind of a surprising level for background CO2. It's very high compared to what it was when I started in this field or when I was born. But anyway, 420 ppm is the kind of background, and you can see spikes that go over 250 parts per million above that background. So this is local pollution in the Fairbanks area getting up to high pollution levels. And you can see a lot of the times when there are particle pollution, there's also carbon dioxide pollution, but the ratio between these varies a good bit. And that's something we really want to understand. So on this slide, I show a heat map showing the PM concentrations versus the carbon dioxide concentrations. And you can see there are some pollution events where there's lots of particles, but very little carbon dioxide enhancement, while there are other events with fewer particles, but much more carbon dioxide enhancement. So this is something that can probe both emissions factors, the emission of particles per CO2, and additionally scrubbing of the pollution. Some of this time appears to have been scrubbed by ice fog. One of the people talked about ice fog, and we did have a lot in January. So that's going to be interesting in looking at these data. So these are all in preparation for the big alpaca field study, which we're going to have next winter, a large natural science study to try and understand the outdoor air pollution. And then additionally, we heard from the community concerns about indoor air. So we're going to be looking at indoor air pollution in addition, and try and understand indoor air pollution, infiltration, and heating related sources with really intensive measurements at a single house in the downtown area of Fairbanks, asking the questions that we have below. Again, SnapTech is the core of this, and then we're hoping through other funding to have other studies adding on to this to make the broader alpaca goals come true. An aspect of this study is engaging the community, and that's going to help us to broaden out the project from this single house to more of the broader community around here. So Professor Laura Connor here at UAF is leading a citizen science project, which is going to ask questions related to indoor and outdoor air quality, but it's going to be an authentic community-driven research project. So we're not prescribing what this group will do, but the group will form, we've already started that process, and design a set of questions, maybe like the questions we have listed on the right here, but they're free to do what they want. And then we will work with them to try and answer those community questions. Because this will occur at multiple households, maybe 15 to 30 houses, depending on what they decide, it's going to get us a window into the broader housing stock and the broader area around Fairbanks, and things like indoor air quality, which we know to be very variable house to house. A key part of this problem in Fairbanks is also related to community perceptions, because as I showed you, a lot of the pollution is ground level pollution, things like driving cars, things like heating homes. And we have a lot of different heating sources like wood, which can put out a fair amount of particles compared to the amount of heat you get out of it. So there are a lot of community perceptions around this. And we want to understand that better through social science research led by Professor Nathan Kettle here at UAF. The pictures that we show here are one of citizens suing the EPA to get them to enforce the Clean Air Act. Another picture here is showing a ballot initiative. In Fairbanks here, people didn't want the community to, the local government to regulate air quality. So there was a citizen initiative which was saying they didn't want the local government, the borough, to regulate air quality. And in fact, that passed. So we see these aspects of people wanting the freedom to burn whatever they want, and then people concerned about air quality. So we want to understand those concerns from the community. Our mayor here gives the idea that we do care about our freedoms here in Fairbanks, definitely, and in Alaska in general. But we need to figure out ways to clean up our air also. So how can we balance these? So Nathan's going to be leading a set of survey work understanding these aspects and understanding community perceptions on how we can address this, maybe through regulation, education, incentives, things like that. That has an underlying aspects of why people have those concerns, and we're trying to get at that also through this study. So what do people perceive as the risk of air quality? What do people perceive as uncertainties related to air quality, or uncertainties with respect to the risks? Additionally, uncertainties can be related to trust. Do people trust the measurements? Do people trust the government? So we're trying to get at these aspects. And then particularly with wood heat, you know, it's a pretty emotional thing to sit near a warm wood stove on a cold day or being out there chopping wood. So there are a lot of feelings, memory, and experience that are also related to the experience, particularly of wood heat. So we want to get at all of these through survey work and then through a community engagement group, which is going to help us to design air quality strategies related to this. So that community advisory group is facilitated by Krista Haringa here at UAF, and we've started forming this group through kickoff meetings. This is a picture from a meeting we had in North Pole. We additionally had a meeting in Fairbanks a few days later where we had more members of the community involved in this. And we're building up a advisory group that will take past work that's been done in Fairbanks by the community, which has been very successful, as I think you'll see in the next presentation, and build upon that to find more answers and then build those into community-based solutions for these problems. So with that, I'll wrap up my part and just leave you with a couple questions that I thought we could discuss after the next presentation. My contact is at the bottom there, and I'd be very happy to engage with anyone on this problem and just help us to be able to solve these clean air problems for these air quality problems for Fairbanks and then the broader Arctic community. So with that, I think I'll stop sharing, and then we can pass this on to Nicole.
Thanks, Bill.
Yeah, thank you for the opportunity.
All right, thank you, Bill. This is Sarah. I'll do a brief introduction for Nicole while we get her slides up and going. So Dr. Briggs, she is with the EPA Region 10 office, and she's a meteorologist and air modeler. And I think a lot of what she and her team are working on has a great interconnectivity to what we just heard about from Bill and the alpaca study. And I'm personally super interested in that alpaca study. Air pollution issues from wood, whether it's from heating or from smoking, is one of my personal interest areas. So really happy to hear more about that. And also happy to hear what Nicole has to share with us. Back over the summer, there was a lot of people talking about air quality for Fairbanks in various studies. There were some wildfire smoke focused questions, and then there were several different people working on this wintertime issue. And I heard about the BenMap tool that EPA was working on and thought it was a really neat way of looking at this wintertime air pollution issue for Fairbanks, just looking at things a little differently. And I'm excited to hear more about this tool, and I will now leave it off for Nicole. If you have any other things for the introduction that I left out, please feel free to add to that. And thank you so much for speaking today.
Hey, thank you. Can everybody hear me okay?
Yep.
Okay, great. It's a little bit loud here, but hopefully it won't interfere with my presentation. Thank you so much for the introduction. And just a couple of other things to throw out there, since I heard everyone else's great introductions at the beginning. I heard a lot of people talking about wildfires, and it won't be a focus of my talk today, but that's something that I do think about a lot. So if there's any kind of collaborations that make sense to have with EPA, I'd be happy to have a chat with anybody about that. And just, it's really great to hear all the expertise on this call and get to collaborate with all of you. So without further ado, I'm hoping that this presentation will complement Bill's. We actually shared our presentations with each other, so I think it will complement him. I'm going to be talking about a health impacts analysis that we're working on right now to show the benefits of improving air quality in Fairbanks using the BenMap tool. And I'll introduce the BenMap tool throughout my presentation. Like Bill, I just want to point out, I sometimes am using the word Fairbanks broadly, but throughout my presentation, if I say Fairbanks, I'm pretty much talking about the cities of Fairbanks and North Pole, which are very close to each other. And when we think about air quality in the region, we think about both of those cities together, or at least I do. So I do also want to acknowledge that we have a number of collaborators within the study. Primarily, I mean, there's other collaborators here at EPA, but primarily we're working with the Alaska Department of Environmental Conservation, so Alaska DEC, and the Fairbanks North Star Borough. And Bill showed a great picture of the mayor of the borough in his last slide. Did everybody see my slide advance? I'll take quiet as yes. Right, so I'm showing a fairly complicated slide here, but I'm going to kind of walk through it because I want to give you a little bit more background on air quality in the Fairbanks and North Pole area. So the focus of our analysis is on PM 2.5, particulate matter less than 2.5 microns in diameter. And the key message that I want to make with this slide is that the air quality in the Fairbanks and North Star Borough has been improving greatly in recent years, but it's still well above the standards that EPA has set. And that's one of the reasons why we're focusing on this area. So for those of you on the call who might be in the air quality field and intimately familiar with EPA lingo, this slide is showing that PM 2.5 design values exceed the 2006 24-hour PM 2.5 NAAQS while excluding exceptional events. I'm assuming most people on the call do not work in that extremely narrow field, so let me actually go into a little bit more detail on that. Many of you know the EPA sets National Ambient Air Quality Standards, which we also refer to as NAAQS, and we have a standard, a daily standard, so 24 hours, focused on PM 2.5, and the current standards are that when you look at measurements, 24-hour measurements over a 3-year period, almost all of those measurements must be equal or less than 35 micrograms per cubic meter, with a couple of exceptions are okay. And in addition, when we look at the standards, when we look at the data, we only look at days where the emissions could be controlled by local or state regulations. So it's kind of interesting is when we think about air quality in Fairbanks and North Pole, and what this plot is showing here is we're actually just showing data that excludes what we call exceptional events, and that includes any days that are influenced by wildfires. So I want to acknowledge that wildfires are a huge concern for air quality in the summer in Fairbanks and North Pole, but when we're thinking about this from a regulatory sense, it's the winter heating season that we're focusing on, because that's something that can be controlled by the residents and regulators that are in the area. So importantly, if you look at the green, black, and yellow lines here, in comparison to this red line here that says 2006, you can see that, oops, didn't mean to click. You can see that these lines represent monitors that are in Fairbanks, in the city of Fairbanks. And you can see that we're achieving air quality now that is below the red line, i.e. In attainment with the standards. And then if you look at these blue lines up here on top, this is showing a monitor in North Pole. You can see that there's been huge improvements in air quality over time, but we're still sitting approximately 30 micrograms per cubic meter above the standard. So a lot more work to do. And these huge achievements in air quality in both locations are due to everyone's efforts in the area. So Alaska DEC, the Fairbanks North Star Borough, local residents, researchers like Bill, other people who are getting the word out about air quality. I'm just going to add a little bit to what Bill said about what leads to poor air quality in the wintertime in the Fairbanks North Star area. So as Bill mentioned, the worst days, the worst air quality days are often associated with wintertime inversions. For those who don't live in the area, temperatures can get down to negative 40 degrees. And for those of you who spend time thinking about soundings, atmospheric soundings, I'm showing one on the right, which is from one of the quintessential air pollution events that we think of that's representative of very poor air quality in the Fairbanks area. And if you just focus on this little bit right down here, the main point that I wanted you to take away from this is that that's a huge temperature gradient in a very small section of the lower atmosphere. So when we say strong inversions, we mean extremely strong inversions that lead to very stable atmospheric conditions that are using the word trapping the pollution very close to the surface. Of course, when you get down to negative 40 degrees Celsius, you would forgive anybody for using any kind of heating necessary to warm their homes. And wood burning is a common heat source in the area. And so EPA and the Alaska Department of Environmental Conservation and others have done studies on what's contributing to the particulate matter that's in the air during these strong inversion events. And we believe, based on the weight of evidence that we have, that wood burning used to heat homes is a large proportion of what's causing the issues in the area. And so a lot of the regulatory efforts and communication efforts that are going on are really focusing on trying to move away from wood burning and or moving to cleaner types of wood burning. So the goal of the study that I'm working on, and I'm just showing here, I guess probably this would have been a better first slide, but this is the Fairbanks North Star Borough, the little red outline here. And then this yellow circle is a circle around the Fairbanks and North Pole area, for those who like to visually place themselves on a map. So the analysis that I'm working on is focused on showing how improving air quality in Fairbanks and North Pole has positive health benefits for the local residents. And we're trying to focus both on the improvements that have been made to date. So that was that first slide that I showed you that showed huge air quality improvements that have happened. And then thinking about reaching attainment with the standards, what the health benefits may be in the future by reaching those standards. And we hope that this analysis can provide some quantitative data that can help support the messaging that our collaborators, Alaska DEC and the Fairbanks North Star Borough, have ongoing with community residents, and any kind of messaging that's coming from resident groups or other community groups or researchers in the area. Bill kind of alluded to this, but one of the hurdles in the area is that there's always some proportion of residents who don't follow curtailments, which is another word for burn bans. So when these strong inversions or other meteorological conditions that are conducive to poor air quality occur, there are curtailments that are called in the area. And there's always exceptions for people who only have a wood stove or whatever the conditions may be. But there's always some proportion of people who don't follow that. And that's true anywhere where there's burn bans called. But I think it's that is one of the focuses moving forward, is trying to get communications out about why it would be helpful for people to follow those curtailments, because it's worth noting that Alaska DEC has conducted some modeling analyses that suggest that if 100% of people complied with the curtailments, local air quality would be at or pretty close to the standards. So that would be a huge improvement for the area. So overall, we're developing this health impact evaluation because we want to give some quantitative information about what we think is the most important thing to focus on. And the thing that sometimes it's easy to lose sight of is that all of these curtailments and the EPA standards themselves exist because we want to protect residents' health. That's the whole point. The whole point is to reduce the air quality to a level that we think is protective of human health, both for the general population and sensitive populations like children and the elderly and those that are pregnant. So, quick introduction to the tool that we're using. We're using a tool called BenMap that was developed by EPA. And the BenMap tool can be used to calculate both health impacts and economic impacts. Right now, we're focusing exclusively on health impacts, and we'll make a later decision about whether an economic impacts analysis is important. Um, to calculate health impacts, you basically need information on population, air concentrations over time, and the improvement in health impacts that occurs for each incremental change in air quality. It's much more complicated than that, but basically you just think about what the change in air quality has been, the air concentrations between the beginning and the end of your study, and then you think about how that impacts the population that lives in the area. This is a pretty well-tested tool. It's been used in a number of regulatory assessments. But I think that the most important thing, and this is what keeps me up at night when thinking about this analysis, is that the BenMap tool, like any tool, like any model, is only as good as the inputs that are going into it. And so that's what we're trying to do right now. I'm going to give you a brief introduction to the types of data that we're thinking about, and then I'd actually like to ask people in this group for some feedback if they have ideas. Because the most important thing for us is to get the data right, because we want the outputs of our analysis to be representative of the local conditions. So we're conducting our analysis. I'm showing a plot here. We're conducting our analysis over what we call the non-attainment area, which covers Fairbanks and the North Pole. So that's the area where the air quality is of concern. We have a wealth of air concentration data. We have modeling data, we have monitoring data, but the question really is what's representative? And so this is something that we're working closely with our collaborators, Alaska DEC and Fairbanks North Star Borough, on defining how to take short-term measurements, combine them with modeled output that has a lot of uncertainty, and what would be the right combination of data to adequately represent past conditions, current conditions, and future conditions for the area. For our analysis, we use health impact functions, which are basically just equations that are derived from epidemiological studies. So these health impact functions are take the information from the epidemiological studies and quantify for an incremental change in air quality what is the health impact, like impact on mortality, impact on hospital admissions for asthma for an individual person of a certain age. So EPA regularly does a review of epidemiological studies and picks out the ones that we think are most representative of causal relationships between health impacts for health impacts. We also need population data. Luckily, that's easily accessible from the census. And then one of the most important things is we need representative data of local health incident rates. So how likely somebody is to die just in general or to be admitted to a hospital. That's kind of a key piece of our analysis. Mortality data, quite easy to come by. The tricky part, and this is something that we are thinking about very closely, is that we would love to extend our analysis to non-mortality health impacts. And actually, speaking with Sarah, who's organized this call, she was one of the people who pointed us towards, there's a great data set for the Fairbanks area called, or for Alaska in general, called the Health Facilities Data Reporting Database. Which has hospital discharge statistics for 22 regional hospitals. And so this is basically the best data set that shows how often people have been to the hospital for certain health impacts, for health conditions. And that would be a vital part of doing an analysis beyond just a mortality analysis using the BenMap tool. The tricky part is that the data set includes the biggest hospital, Fairbanks Memorial Hospital, but does not include data from the Bassett Army Community Hospital, which is another major hospital in the area and likely some smaller hospitals and health centers. And so I guess what we're grappling with is our analysis, if we use this data set, would be very conservative because it would underestimate the number of people who go to the hospital for certain conditions. For example, we estimate that exclusion of the Army hospital would result in approximately excluding data for about 9% of the Fairbanks North Starborough community. And so I guess one of the things that we're grappling with is what it means to have such a conservative analysis or to have these data that aren't entirely representative of the area. So leaving with that, some of the questions that I have that I would appreciate feedback on, in addition to anything else that you'd love to give me feedback on, is any advice that you have for designing or communicating our study. Keeping in mind that there's both receptive and non-receptive audiences in the area. And then if you have any feedback on the idea of doing a health impacts analysis with incomplete health incidence data for the region, I would love to hear that. So thank you, and I'll turn it back to Sarah, I guess, or whoever would like to lead the discussion.
Great, thank you so much, Nicole. So should we open it up for questions for everyone? Or I have one or two that comes to mind for me.
Why don't you go first?
Okay, I'll do that. Thanks. So Nicole, I was thinking about the hospital discharge database, knowing a lot of these limitations and grappling with them a lot.
I'm sure you do.
Yeah. And it's such a small state, and then you've got, Fairbanks is not the smallest community, but it is still on the smaller side. So obviously, not having every hospital included in the area is a loss, because you want as many people as possible represented to have, data power and whatnot. I don't know that it would necessarily help with this, but there is a syndromic surveillance piece too. It's a little bit, grayer area to work with. Like the hospital discharge database, it's very clear, like someone was admitted, here's our ICD-9 code. Syndromic can look for some more fields, but I still think we'd run into the issue of, especially for the military, base not reporting in, and I just don't know the way around that.
Yeah, I think I've come down to, I actually, Sarah, I'd love to put a plug in to talk to you again in the next few weeks, offline. Maybe we can chat about some
I'm gone
ideas.
next week, but after that, you can let me know.
I am gone next week too, so
all right.
We can enjoy our vacations together. Yeah, I'll send you an email. But yeah, I agree with you. I mean, the way that I've come out is that we just, if we want to do it, it has to be just a very conservative analysis that doesn't include all the data. Because
we've come up on this with a water quality issue there right now, so it's tough.
Yeah, I mean, somebody has suggested to me, like, can you inflate the data set by 9%? And it's like, yeah, you could, but I don't know how I feel about adding additional assumptions into an analysis, by arbitrarily inflating it by amount that we think is correct.
Right.
A thing I might mention here is our community advisory group could be a group that you could bounce these ideas off of. We're involved with some folks, kind of retired doctors and nurses and folks like that. We're forming that group right now, but they may be able to give you some information about the hospitals. And additionally, particularly with respect to Bassett, is I think they serve a kind of different population. A younger military population. I think there's a lot of babies, because they're kind of that age, the people who are there. So you may find, I'm not sure if inflating is the right thing to do, because the population served is probably a bit different. And I think you could talk to some local people to try and get some good input on that.
That's great. Would you be the point of contact for that, Bill, or?
I wouldn't be I could put you in contact with the people, but I wouldn't be the main point of contact. I mean, I'd be happy to facilitate it.
Great. I'll send you an email.
Yeah, sure.
All right, does anyone else on the call have any questions for either Bill or Nicole?
If no one else has questions, I think, I've been following the alpaca campaign closely and hope to be involved, but I would love for Bill to expand a little bit on, you didn't go into what I think is one of the coolest things, Bill, which is all the measurements that are going to be there. It might be worth if you want to spend a minute or two talking about that.
Sure, I could talk about it for a second. I'd actually first like to just say that we really hope to work with you and any others with the social science work that we're doing to try to get the information we're learning about the community to help to address how you can reach the community, essentially. So we definitely want to work with others on that social side. With respect to the natural science measurements that we're going to have next year, it's going to be amazing. It's going to be an incredible jump in the measurements that we have had in the past to what we're going to have into the future. So there's going to be 5 groups in addition, 5 universities in addition to UAF who are going to bring truly state-of-the-art instrumentation and expertise to bear on this problem. And one of the things I think of is, there's going to be a lot of real-time instruments, essentially 5-minute type measurements of particle composition. And really everything we know about Fairbanks pollution in the wintertime in the past has been 24-hour filter samples and then a little bit of hourly data that doesn't know the chemical composition. So we're really we're going to take it from a time scale that is integrating over the full diurnal cycle, the driving cycle, the burning cycle of wood stoves, and take that to 5-minute data that's going to get us a huge amount of increased information. So we're extremely excited about that and excited about going to the indoor environment and seeing what happens to particles when they're brought indoors and they warm. They're going to warm by massive amounts, 20, 30 degrees centigrade. Even 50 degrees centigrade is possible depending on how cold it can get. And what's going to happen to the particles? We want to understand those.
Bill, I was curious how much diesel vehicles might be contributing to, or off-road large engines and stuff like that.
Yeah, great question. And so interestingly, when we had the ice fog this winter, diesel smell was horrific. I mean, that's just anecdotal and, it's not quantitative, but we're going to be quantitative next year. So it's going to be great to see that. The past analysis hasn't indicated that much role for diesel in the general Fairbanks area, but it's something we're definitely going to be looking at, and with the greater detail, we're going to get at that. Off-road vehicles, and it may be that there's a small amount of plowing which occurs by, like graders and things that may be running off-road fuels, but I'm not sure if those are, I don't think those probably contribute that much of the overall problem, but it's something we're going to be able to get at.
Are there generators running as well? And it's just a problem, electrical problems, or?
Yeah, so that there are a few emergency generators around. There additionally is some combustion of naphtha that occurs at a power plant that's in the North Pole area. Yeah, I don't really know a great answer to that. Unfortunately, for what we have funded for the SnapTech project, it's really focused on a house, and we picked a Fairbanks residential neighborhood that is in between the North Pole pollution levels and the pollution levels that you saw for downtown Fairbanks. So I did want to point out that Fairbanks has regions that are more polluted. So we shouldn't think of this as Fairbanks and North Pole. It's really residential areas that are the more polluted areas. So we'll be in a Fairbanks residential area, but we won't know about unique things about some generator that's distant from where our house is. So hopefully some other co-funding will bring in a mobile lab. We don't have mobile lab at this point funded, but we're very hopeful that a proposal would get funded on that.
Great. All right.
And just to add to that, there have been some mobile measurements over the years, which I know Bill's aware of and been involved in. But you know, some of those mobile measurements actually led to the sighting of a new monitor right in the area where Bill's house is going to be. I guess it's not Bill's house. You're not going to be living there, are you, Bill?
No one will live there. It's going to be unoccupied.
So there have been some mobile measurements, and certainly things like generators and other, you know, other things can contribute. But really, it's a lot of the, you know, really in the most polluted areas, it's a lot of the personal systems that are set up for wood burning, whatever,
Great.
whatever there may be.
Well, I'm really excited to hear that the Alpaca team is working with the community and working with the health effects experts, because that's the best way to get the data to improve your modeling and understanding of the health effects of air quality, air pollution.
Bill, this is Stephen Peckham. Can everyone hear me?
Yep.
Yeah, I got a question. You know, between North Pole and Fairbanks, there's Fort Wainwright. I don't know how much you're going to be able to get out there on the fort and who you're working with that you might be able to at least get some measurements out there.
Yeah, that's a great question. And so we've been working with Martin Stufer, who you're working with on the ice fog project, and we're really interested in that project. We have been operating on the base this year through some funding that came from the base to try and understand different neighborhoods around there. It's been very exciting to be in neighborhoods with different dominant heat sources. And there is a neighborhood in the base which is only heated by natural gas, one that's only heated by oil, and then we're comparing to a neighborhood in Fairbanks with the mix of heating sources. So we're hoping to get more knowledge of primary emissions from those studies. Just kind of anecdotally, this winter, we've been seeing pretty clean air on the base, particularly in that natural gas heated neighborhood. It's on the edge of town, and we seem to have some wind pattern there that's bringing in clean air to that area. So it's a definite interest. And then with changes to the heat and power that's going to be generated on base with their power plant, it's a coal-fired plant, probably shutting down soon. That will be a big issue for the area. Also for ice fog, because if they go to, like, say, natural gas as a heat source, that's going to put a lot more water vapor in, which could cause ice fog.
Yeah, and you brought up then the winds that are in that area and some microscale differences. Are you, so what are you doing in Alpaca to capture these very interesting wind patterns that ebb and flow across the Fairbanks area?
Yeah.
Yeah, you know, and it was pointed out by the other speaker how shallow that inversion is. And we know from historical papers how that can vary across the valley itself. So I think capturing the winds, the temperature profile, the moisture, that meteorological aspect is of interest, because before you go to the chemistry, you know, and get that dessert, you have to have your salad, get the weather right. And, you know, the models aren't going to do it. The models can't capture any of that. So, you know, after 15 years of running WRF, I'm not going to start up a WRF run and make that forecast. Forget it. It's done. So what are we going to do to get the weather right?
That's a thing where we really need collaboration. What we were funded on in SnapTech really is an indoor-outdoor study around a house. So it doesn't have a horizontal spatial aspect to it. You're absolutely right that the pollution that comes to the house is highly affected by the meteorology around that house. But because the study was really a kind of indoor-outdoor at its core, we don't have a horizontal nature to it. And so we really want to have collaboration with Martin's group, other groups, other proposals to NOAA or NSF or anybody who can help us with the meteorological aspect of this problem. So yeah, it's a huge thing that we would really like. But SnapTech's goals were not to understand the spatial horizontal distribution really. So it wasn't a part of that grant, and we don't currently have very much funding to do that. So yeah, we need it. And we hope that collaborators will be able to bring that.
Okay, because
I'd love
if we
to talk
had
to you more.
something,
And we've talked
if
with
there was,
Martin,
go ahead.
I was just going to say, I'd love to talk with you more offline and just anyone to make this happen.
Okay, yeah, I think our challenge that we're getting right now is we have some good profiles of temperature, but the winds are eluding us, especially in that first 100 meters or so. We're trying to figure out what we could do. Of course, launching balloons in Fort Wainwright, that's tough. Yeah. But I have talked with the staff weather officers there. I've spoken with the captain, and they're willing to help out. We could launch balloons with them. I don't know where the money's going to come from to get the equipment, but we can do some meteorological analysis with the staff weather officers. I'll end it there. Thanks.
Yeah, so there is an international proposal from the Swiss to bring a tethered balloon to do some vertical measurements. Getting that permission to fly and to what altitude we can go to are big questions. But yeah, tethered balloons are certainly a good way to get at it at specific horizontal points where you can launch a balloon. There are 2 airfields around here which limits our ability to do things that are free flyers.
That's some great feedback. Certainly, these very shallow inversions are really hard to get right in the models, and having good meteorological measurements. Hopefully, some of your partners get funded to do the mobile lab and the launch some balloons and get you a more 3D picture of what's happening.
Yeah.
And just to put a plug in, Alaska Department of Environmental Conservation is working on updated WRF modeling for the area. It's, of course, an area of concern trying to get the modeling right. So if there are any measurements and whatnot, I'm sure that Dee would love to be included in those conversations. Bill, I'm sure that that would be data she'd love to get her hands on. But you probably have her in the loop.
Yeah, and so we definitely want to get this all together. If anyone's interested in this, please contact me, and we're going to have a planning meeting for the SnapTech group that's going to be the 1st and 2nd of June this summer. There'll probably be a second planning meeting later in the summer because many of the groups that have applied for funding won't know by the first planning meeting. So that first planning meeting will probably be focused on the house logistics, and then our concept is one towards the end of summer, we'll probably be planning for broader aspects of things that are funded through other agencies or other parts of NSF possibly.
Great, thanks. And I will type those notes up and post them on the event page for this event that I'll post in the chat box right now as well. So that kind of call and announcement will be here also. And of course, we always encourage you to, if you want to make a specific post about that on the IARPIC Collaborations website. It might be helpful to bring in others who weren't able to join on the call today. And with that, I think we're 10 minutes over, and I want to respect everyone's time. And if Sarah or Barry, you have anything else you want to say?
Just my last, it'd be great to have Bill and Nicole back after their study's over so we can see what they learned and see how that, or at least I know research is never over, but early results, and when you get your first good BenMap results, that would be great to see what you learned. And what other question? What are your questions now that you've done all this other work? So anyway, thank you, everybody.
Thank you.
Thanks.
Thank you. Bye.
Bye.
Bye. Thanks.